Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and in this lesson we're going to look at timer 1 of the 16F88, which is a 16-bit timer. Now what I'm going to do is I'm going to reuse the 8-bit timer program that I had and just modify it slightly for the 16-bit timer. So firstly what we're going to do is we're going to pop back to the document 16F88 document, and we're going to take a look at timer 1. So this is the timer 1 module. And just to read a few things about it, timer 1 module is a 16-bit timer or counter consisting of two 8-bit registers. These are TMR1H and TMR1L. Now these stand for the H and the L stand for the high byte and the low byte of that. So it's split into two bytes because obviously these are 8-bit microcontrollers. And these are readable and writable. The TMR1 register pair, so TMR1H and TMR1L, increments from 0000 hex up to FFFF hex. So that's 16 bits all in all. If that was in decimal, and you can check this, it should be 65,535 would be FFFF. So a much larger number than the 255 which we would have got from the 8-bit counter. Sorry, the 8-bit timer. So the TMR1 interrupt, so again we know that there's an interrupt now, if enabled, so we know we have to enable it, is generated on overflow, which is latched in interrupt flag bit TMR1IF. So remember that TMR1IF, but it's quite easy to remember because we dealt with the timer 01 earlier, and that was TMR0IF. So these are all very like each other in their names. The interrupt can be enabled or disabled by setting or clearing TMR1 interrupt enable bit TMR1IE. Again, that's very similar to the TMR0IE that we used earlier. Now the next little bit is all about the about using it as an oscillator for a secondary clock source. So we're not going to look at that for the moment. What we want to move on to is how to actually operate it. So timer 1 can operate in one of three modes. It can operate as a timer, or as a synchronous counter, or an asynchronous counter. The operating mode is determined by the clock select bit TMR1CS. Now if you go and look at that TMR1CS, that bit in the T1 con, you'll find that a 0 or clearing that will set it to be used as a timer rather than a counter. So that's clearly something that we're going to want to do. Now as it may happen, if you forget to do that, you will probably get away with it because I think it defaults to that anyway. But just be careful. I think it's better to be explicit about what you want to do and actually write it down anyway. In timer mode, timer 1 increments every instruction cycle, and in counter mode it increments on every rising edge of the external clock input. Timer 1 can be enabled or disabled by setting clearing control bit TMR1 ON. Now be careful, this mention of enable, you may think that that's something to do with the interrupt, but in actual fact this actually tells the timer to switch on or switch off. In other words, start moving or not moving. This is not something that we've seen in the previous one. This seems to be something just for timer 1. So clearly what we're going to have to do with this one is we're going to have to actually set it running by saying TMR1 ON. We're going to have to enable that by setting it to 1. Okay, and that's most of the important information. So just I wanted to show that to you before I started to put it into the program. So we'll go back to our user. Let's see here. And so some of the things that I want to put in, we don't need this T0CS that was related to the timer 0. What we do want to do though is we want to have the TMR1CS, which is the equivalent one for timer 1, and we're setting it up as a timer, so we're going to clear that value there. And as I said, that'll probably happen automatically, but you're better off setting it for definite. Okay. We've enabled the timer 0 interrupt here, so I'm going to change that to 1. That's now enabled the timer 1 interrupt. We've enabled the global interrupt enable as well. Now, just be a little bit careful here. There is another enable bit, and it's called the PEIE. Okay, and it's for peripheral enabling of peripheral interrupt enables, and we're going to enable that, or we're going to set it to 1. Now, I'll just show you where that is, but it's not at all obvious. And one of the problems when you're looking at the data sheet is that when you look at this one to do with the timer 1 module, and indeed when we looked at the timer 0 module, it didn't mention the global enable of the interrupt, and yet we still had to do it in order to get it to work. This one doesn't mention the global enable or the PIEI. So let's have a look at what the PIEI is. And this is something that unfortunately you just have to learn from experience. Sorry, PEIE is what I meant to say. Okay, so we can see it mentioned here. It's in the intcon register. It's right there beside the global enable there, or interrupt enable, PEIE, and it's to do with peripheral interrupts. So clearly, what this has done is it's separated it into separated the types of interrupts into global ones and peripheral ones. Okay, we can see here, if using interrupts, ensure that GIE and PEIE bits 6, 7, and 6 of the intcon register are set. Okay, and what that basically means then is that we can use PEIE at some stage later if there's certain interrupts we want to disable, but not all of them. Okay, so it probably wouldn't disable the timer 0, and it is beyond likely to disable the external interrupt, but it would disable other peripheral sort of ones, which would include the timer 1 interrupt. Okay, so just be aware of that. It's something that isn't obvious from the little section that you read on the timer, so it's one to just be careful of, or otherwise you won't know why it's not working for you. Okay, we'll go into oh sorry, the other thing I wanted to do, which we mentioned when we were going through it, was we needed to set this one TMR 1 on. In other words, I'm turning the timer on to set it running. Okay, now you could also set that elsewhere if you wanted. You could set that running in main if you felt like it, or wherever, but we're just going to set it running from the get-go. We'll go into interrupts and just check what we have. So I'm now not looking for the timer 0 interrupt flag. I'm looking for the timer 1 interrupt flag, and again I want to clear that when the interrupt occurs. So when the interrupt occurs, we check for that flag set. If it's set, it means that it was that flag caused the interrupt. We need to clear that flag so that it's ready to go again, and or otherwise, as you may have seen in a previous video, what will happen is it'll immediately hold the interrupt again as soon as we've left, because it thinks that the interrupt has happened again, whereas in fact it hasn't, because there hasn't been another overflow yet. What we're then going to do is we're going to update that counter that we had previously. Our main doesn't have to change at all. It's the same. The count is going out in port B, but what we should see is it's running at a much slower rate than we saw for the 8-bit timer, because it's that much longer. So I'm going to do a debug run there. And you can see here I've stopped at my breakpoint that I set in the previous program. I set a breakpoint inside the interrupt service routine at the counter 1, and we can just see this running again. So if I run once, we can see that the output there on port B has gone to 1. If I run it again, it's gone to 1 0, and if I run it again, it's gone to 1 1 and then to 1 0 0. What I'm going to do though then is I'm going to get rid of that breakpoint, and I'm going to let this run freely. You should see it updating, and you should see it updating correctly, because of the fact that there's now a much longer time. It has to go through 65,536 instruction cycles before it updates the counter each time, and therefore updates the port. That should be slow enough for you to see it now. Okay, and you can see it updating itself there. So the least significant bit there, it's going through it fairly fast, but some of the other bits are quite slow to update, because it's taking a bit longer to count up to that point. Okay, so that's enough just to show you the 16-bit interrupt, and then we'll be looking at some other, if we want to set a very specific time as opposed to just using the full extent of the timers in some of the next videos.